Generally, periodic table, you have the 6 periods and 8 weeks. After that, what? This is the periodic table proposed by Mr. Bostic. He constructed the periodic table based on the atomic number. Now, we are going to observe the Bostic's periodic table. We will observe the periodic table. 7 periods. Horizontal hold on periods. Periods. Similarly, vertical columns. Horizontal period. Vertical column. Now we give out so if we observe here nitrogen is to second to the 18. At the same time, we observe the numbers which are 1 to 7. Nitrogen, 7, 18. These are the 7 periods. Now, if you are going to observe this, so what we said, what we have to elements possess any same number of valence. What we say, first we are the Roman number of 1A, Arabic number 1A. Here we are using nitrogen, third atomic number, and if we observe what we kept first column, those elements which balance same number of elements. Every group take what hydrogen balance shell has same number of elements. So still should have same number of shell. Similarly, we have taken very good like calcium, French, those are all the same number of tools. So that is the second point we want to select the take. Means the number of shells increases as the load of the group. So what we want to say here, hydrogen is 1 is 1. Lithium is 2s1. 1 is second, third atomic number 2s. That means we are sodium ts third, fourth. It means what? As we go down, what is going to be the number of shells are ts like that. That is said by the after that, let's the point C here. Any same so, okay, but it left right balance. Okay, so we will okay. If we have taken here hydrogen in the same period from left to right. Like the group, is 1 and helium is 1 is 2. That means number of electrons are increasing in the same shell itself. So we can observe that the group number of shells increases period in the same shell. Number of electrons are increasing. Yes, it's right. Now, second period, lithium. The next element is second shell lithium. Yes, is sufficient. It is one element. In the middle is the four second one element. Yes, one and two. Yes, two, one. Two, two, three, of five, six. Till the ending of the group, the shell is not but as like group, no enhancement of the shells. The period left to right shells. This is the period. Next, each period marks new electron shell. So, first period లో మనకు వచ్చేది only first shell. 1s1, 1s2 అని. At the same time, what? Next, second period లో చూస్తే second shell fill అయిపోతుంది. Third period మొత్తంలో చూస్తే
Sir, voice not clear. Please check.
థర్డ్ పీరియడ్ లో చూస్తే థర్డ్ షెల్ మొత్తము ఫిల్ అయిపోతుంది. ఫోర్త్ పీరియడ్ లో చూస్తే ఫోర్త్ షెల్. అట్లా ఎవ్రీ పీరియడ్ కి a new shell we are going to observe here. So
Now it's clear.
now in this manner, the mostly constructed the periodic table. So how many number of groups and how many number of periods now we have known. Similarly, what are the numbers he has given? 1 to 18 is what in the periodic table. Now we are going to see, right? What children observe the periodic table once clearly. We have the Arabic numbers in the 1 to 8, 1 to 18. And similarly, if you will see the Roman numbers 1a, 2a, after that 3a will be starting from the Buran onwards, and 4a, 5a, 6a, 7a, and last zero group is K. In the middle of the periodic table, we have it was started from 3b to 2b. So what are these? And finally, at the bottom of the periodic table, separate lanthanate series, actinate series, it was mentioned. What are these? What? Why the Arabic numbers? Why the Roman numbers? Why this type of differentiation came? What is the meaning of that? And how can we explain this? We will see these explanations short. Okay, next. So modern periodic table. The modern periodic table elements are arranged in the increasing order of their atomic numbers that already we have discussed in the form of table having 7 horizontal rows and elements called periods. 18 vertical rows of developed. These are called groups itself. Now, periods, if we will see, let's have a discussion, have a complete picture, have a complete idea regarding the periods. Children, we know that already how many periods we have in the periodic table which was proposed by the mostly 7 periods. There are 7 periods of elements as follows. First period has 2 elements, hydrogen and helium, called very short period. Observe the periodic table, atomic number 1 with the orange color, and helium 2, that is the second element, that is considered as the first period, and this is the shortest period in the periodic table. Why shortest period we are considering? Only 2 elements, that's what hydrogen and helium only can have the elements in the first period. That's why first period has 2 elements, and hydrogen and helium are called very short periods. The second period has 8 elements. That's where from where to where? Lithium to neon are called short period. Now if you observe from the atomic number 3, the second period horizontally, if you are going to observe, third atomic number lithium, fourth beryllium. In the similar manner, in the straight manner, if you are going to observe, The last element is the noble gas element neon. Atomic number is 10. So this is the second period which contains 8 elements. Once you count lithium, beryllium, boron, carbon, nitrogen, oxygen, chlorine, and neon. We got 8 elements here. This is short period. First short period we can call. The next period is third period has similarly 8 elements from sodium atomic number 11 to argon atomic number is 18. It is also called short period. Second short period we can call. First one is shortest period. First short period is the second period. Next second short period is the third period. Atomic number 11 నుండి argon 18 వరకు. So till this elements we have in the third period 8 elements. Easily we can remember this. First period 2, second period 8, third period 8. 2, 8, 8 elements we have in the 3 periods continuous. Coming to the fourth period has 18 elements. That is from where to where? Potassium to krypton, or called the long period. First long period itself. Why? Potassium 19, calcium 20. The middle of the elements also started from the scandium to zinc. These 10 elements which are coming D block, these are also calculated for the fourth period, counted for the fourth period. So by means from potassium 19 to krypton 36, if we will count the elements, 18 elements we are going to get. Those 10 extra elements are added in the middle of the periodic table if you are going to observe, which is in blue in color itself, from scandium to zinc. Similarly, fifth period, it has 18 elements from rubidium to xenon, or called the love. Sixth period, if we have seen 32 elements, cesium to radon. So what they are saying? Cesium to radon. Once you observe in the sixth period, the atomic number of cesium will be 55 and the radon atomic number is 86 itself. Once you count, students, cesium to radon, if we will count the same number of elements what we got in the fifth and fourth period, 18 elements only we will get. But how we are getting 32 elements? Once you can observe, cesium is 55 and 56 is the barium. After that, 57 is the lanthanum. You know that the periodic table is constructed based on the atomic number increasing manner. అంటే పరమాణు సంఖ్య పెరిగేటటువంటి క్రమంలో ఈ పీరియాడిక్ టేబుల్ అమర్చడం జరిగింది. అయితే 57 ఆఫ్టర్ విచ్ నెంబర్ వీ నీడ్ టు గెట్? 58 వీ నీడ్ టు గెట్. లాంథనం అక్కడ రెడ్ కలర్ స్టార్ మార్క్ లో కనబడుతుంది. మీకు థర్డ్ బి గ్రూప్ లో థర్డ్ ఎలిమెంట్ నిలువుగా చూస్తే, దట్ లాంథనం హ్యావ్ 57 atomic number. After that 57, in increasing manner of the periodic table, 58 we need to get. There is no 58 in that place. Where it is? At the bottom of the periodic table, lanthanate series, a separate series is there from 58 to 71. That is from cerium to lutetium. Those elements also taken into the consideration as the sixth period elements. అంటే ఈ ఎలిమెంట్స్ కూడా మనం సిక్స్త్ పీరియడ్ ఎలిమెంట్స్ లాగే కన్సిడర్ చేస్తున్నాం. That means 57 after 71, up to 71. After that, 72, 73, 74, and up to 86. So from 55 to 86 are considered as the sixth period elements itself. After that, next, seventh period has 28 elements from Francian to atomic number 114 itself. So once you observe seventh period, 87 to 113 are here in this table. Up to 114, we are considering it is an incomplete period. Why? Because in coming days, maybe some new elements may invented, some new elements may be discovered. Because of that reason, it is an incomplete period. That period was not completed. That's why the seventh period is having right now 28 elements from francium to atomic number 114, called incomplete period. 14 elements each of sixth, seventh period are placed separately at the bottom of the table. Now only I told 57 after, lanthanum after that 18, actinium after, thorium to laryntium. Similarly, cerium to lutetium. These are the 14 elements are placed at the bottom of the periodic table. Lanthanum after we are keeping the elements. That's why it can be called as lanthanide series. The actinium, after we are keeping the series from thorium to lawrencium, that is called as actinide series. These are every period consists of what? 14 elements. So these 14 elements, each of sixth and uh, seventh periods are placed separately at the bottom of the periodical table. Those are called lanthanides and actinides. The 14 elements of the sixth period from lanthanum to lutetium are called lanthanides. Already I told. And the 14 elements from the seventh period of from actinium to lawrencium are generally called or what? Actinides itself. So majorly students is to observe what is the short period, shortest period, long period, and how many elements we have. 2, 8, 8, 18, 18, 32, and the incomplete period. How many elements easily we can remember itself. This is the information regarding the periods, how he has constructed and what are the elements they have, how the number of electrons are going to be increases, how the shell every period by period, how the shell is going to be changed itself. I think you got the idea regarding the clear idea regarding the periods. Now we are going to discuss about groups itself. Oh, let we know that already in the Moseley's periodic table we have 18 groups. There are 18 groups of elements divided into 9 main groups. They are 1, 2, 8, and 0 group sets. See, students, 18 groups are present as the vertical columns. Initially, I told with the Roman numbers, sorry, with the Arabic numbers are present 18 groups. I told. In this, if you will see, they are 1 to 8 and 0 groups, including that total 9 groups we are getting. 1 to 8 Roman numbers are there and 0 group. So 8 plus this 0. Total how many groups are there? 9 main groups are there. And the groups from 1 to 7 has 2 subgroups, each called A subgroup and B subgroups itself. Group 8 has 3 rows of elements and the 0 group has 1 row of elements. Means what? Once you observe the periodic table, students, if we are giving the Arabic numbers, total groups we are considering 8, 18. 18 groups we are saying that. But with the Roman numbers, if you are going to give 1A, 2A, after that, the B subgroups are in the middle of the periodic table. We will discuss it later. After 2A completion of that, 3A, 4A, 5A, 6A, 7A, and 0 groups. So total how many groups are there? Till now, 9 groups are come. After that, the groups which are in middle, they are separated as B groups based on some properties that we will discuss later. So if we will add these are all the groups, we are going to get a total 18 groups. And especially in the D block, the blue colored D block elements, if you are going to observe with the atomic numbers of 26, 27, 28. Similarly, 44, 45, 46, 76, 77, 78. That is ferrous, cobalt, nickel, ruthenium, rhodium, palladium, 76, osmium, iridium, platinum. These are the 3 groups can be considered as one group only, that is 8th B group. Similarly, yesterday we have discussed in the Mendeleev periodic table, these elements also considered as one separately, one group he has considered, Mendeleev also. So in the similar manner, mostly also considered as these are the one bits. After that, now the A subgroup elements are called normal elements and B subgroup elements are called transition elements. చూడండి, నాకు 1A, 2A, 3A, 4A, 5A, 6A, 7A, these are A subgroups. ఈ A subgroup elements ని ఏమంటున్నాం మనం? Normal elements. And B subgroup elements are transition elements. So what are normal elements? What are transition elements? That we will discuss later. After completion of the periodic table, those will come into the discussion. So finally what? A subgroups are called our normal groups. B subgroups are generally called our transition elements. This is normally based on the configuration, based on the d orbital, we can discuss about regarding these things. Okay. Now, lanthanides and actinides are called inner transition elements. Actually, these subgroups are called transition elements. After 57 only, 58 is there or not? After 89 of actinium only thorium is present or not? These are the elements which are kept at the bottom of the periodic table. Those elements from cerium to lutetium and thorium to laryntium, they came from the this B subgroups only. Those are transition elements, and especially from the transition elements only, we are taking the elements in a separate form or in a separate manner. From that transition elements only, these are the elements or we are keeping outside. Because of that reason, they can be called as inner transition elements. What is the definition of transition elements? Why we are calling transition and inner transition elements? Let we will discuss it later. Okay. So now group 1 elements are called our alkali metals. So once you observe children, group 1A, what are the elements? Hydrogen to francium. I'm reading that hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. These elements are called our alkali metals. And from the second A group, if you will consider, those can be called our alkaline earth metals. Those can be called as what? Alkaline earth metals. And group 17 elements are called halogens. Group 17 elements are called halogens itself. So similarly, what it was first A group is called as alkali metals. Second A group is called as alkaline earth metals. And third A group, which was is in green color, the atomic number of boron, it can be called as boron family. And the fourth A group, it is called as carbon family. Nitrogen is a nitrogen family. Otherwise, we can call her pictogens. And after sixth A group, but oxygen family can be called as chalcogens. And seventh A group, those can be called as halogens. And the last group, zero group or 18th group, those can be called as noble gases, inert gases, rare gases. Once again, first group is alkali metals. Second A group is called as alkaline earth metals. Third A group is boron family. Fourth A group is carbon family. Fifth A group is nitrogen family or pictogens. And sixth A group or oxygen family can be called as chalcogens. And seventh A group is halogens. And the last zero group or 18th group are called noble gases. Otherwise, we can call as rare gases, inert gases, stable gases also can called it. Group 18 zero group are called noble gases. It's in a group, all the elements have the same number of valency electrons. Group 1 elements have one valence electron. Group 2 elements have two valency electrons. Group 3 elements can have three valency electrons. In a period, all the elements all contain the same number of already we have discussed that. Again, see here. L, first A group elements all can have in its valency shell only one electron. Second A group లో valency shell ఎన్ని electrons ఉంటాయి నువ్వు ఏ element అని observe చేసుకుందాం beryllium, magnesium, calcium, strontium, barium, radium. Whatever the element, if you are going to write the electronic configuration, you are going to get two electrons only in the valence shell. మరి థర్డ్ గ్రూప్ లో ఉన్న ఎలిమెంట్స్ అన్నింటికి కూడా త్రీ ఎలక్ట్రాన్స్ ఇన్ ద valence shell. ఫోర్త్ గ్రూప్ ఫోర్ ఎలక్ట్రాన్స్ ఇన్ ద valence shell. మరి లాస్ట్ గ్రూప్ లో జీరో ఉన్నది కదా అంటే జీరో ఎలక్ట్రాన్స్ ఉన్నట్ట ఇట్స్ నాట్ కరెక్ట్. యాక్చువల్లీ 8 electrons are present in the valency shell, which is the eighth group. And thus, it was completely stable electronic configuration is there. That's why we are calling what zero group itself. By means it's not zero electrons, no electrons are present. Note, do not consider like that. Completely stable electronic configuration, octet configuration is there. Because of that reason, we are calling it as zero group generally. So this is about the information regarding the groups and the periods. After that, in a period, all the elements contain the same number of shells. Already we have discussed this point. The next point, if we will see trends in physical properties. Right. Before going to discussion about this, once again, we will go to the periodic table. The first A and second A group, if we will observe, the electrons, valency shell electronic configuration of hydrogen is 1s1 and beryllium is 2s2. Both the first A and second A groups considered as S block. Why we are considering S block? Children, we have four subshells: S subshell, P subshell, D subshell, as well as F subshell. So the periodic table is constructed based on the increasing of atomic number. That's right. Fine. In the atomic structure, already you know about regarding the shells and subshells. So based on that, if we observe the periodic table, based on the increasing of atomic numbers only, that was constructed. But in this periodic table, the classification done based on the electronic configuration also by means S block, P block, D block, and F block. What are these blocks? If the valency shell electrons are going to enter into the S subshell, whatever the elements present in the periodic table, if the valency electrons are present after writing the configuration, the last electrons, the core electrons, if they are present in the S subshell, those can be considered as S block elements. Any element you can take and write the configuration: lithium, potassium, rubidium, strontium, barium, whatever it will be. First A and second group elements we are going to observe. Valency electrons will be present in the S orbital. That's why those can be called as what? S block elements. After that, from boron onwards, if we will see, from the boron to neon as well as the helium, it can contain what? Every element can contain the electrons is definitely filling into the p orbital only. Because of that reason, every element from boron to neon means boron family to noble gases, the electrons, the valency electrons can be filled into the p orbital. That means p subshell. That's why the total groups from third A to zero group can be considered as p block elements. P block elements itself. And S and p block up to seventh A only can be called as what? Representative elements generally. SP block and representative elements we can call. The middle of the periodic table, if you are going to observe from third B to second B itself, scandium to zinc, yttrium to cadmium, anthonium to mercury, actinium to 112 elements. So these are the elements definitely have the electronic configuration in the d orbital level. So because of that reason, this block can be called as d block. Similarly, at the bottom of the periodic table, continuously the electrons are going to fill into the F subshell. Because of that reason, the lanthanide series and the actinide series can be called as F block elements. The general configuration, general electronic configuration is also available for the every block itself. Okay, right. Next. So what? Mendeleev periodic table after mostly modern periodic table. How many periods? How many groups? And what type of blocks? What elements they can call? We have discussed. Now, the physical properties of the elements, how they are varying in the periodic table. What are the properties we are going to discuss in this periodic classification lesson? We will see once. First one is atomic radius we will discuss. Ionic radius will discuss. Ionization enthalpy, electron gain enthalpy, electron negativity, oxidation states, as well as chemical reactive states. Okay, so uh, before going to before going to discuss about these physical properties and how the variations are going to occur in the periodic table, first of all, how we will write the electronic configuration? How can we write the electronic configuration? Once we will see. For example, hydrogen, if we have taken 1s1 is the electronic configuration. 1s1 is the electronic configuration. Now you observe which is in blue in color, it represents the shell number. Shell number, it is the possibilities are what? 1 to 7 itself. What is the shell number it is representing? And yes, which is red in color, it is giving the representation of subshell possibilities are S, comma, P, comma, D, comma, F. 4 subshells are there. And the electrons which are present in that, it give the group number. By means what? 1s1 if you are going to write, directly we can say that that elements belongs to which period, which is subshell, the electron is present, and exactly which group the element which it is present in that. For example, if we have taken 1s1 is the configuration. 1s1 element is there. It belongs to which period if anybody is asked? Directly we can say that the blue color number 1, it is a shell number. It represents the period. And S is subshell. S is there. So the electron, first electron which it is present in the S subshell. Similarly, the electron, how many electrons are there in the S subshell? Only one electron is there. So because of that reason, the electrons what it is present in the S subshell, only one electron is there. It gives the group number itself. So 1s1 is there. For example, if we have taken hydrogen after helium, lithium, beryllium is there. Beryllium atomic number how much? 4. 1s2 and 2s2 will be. We have taken 2s2. So first 2 representing the period number. That is a second period. After that, S is the subshell. S is the subshell. And 2 electrons, whatever it is going to given, are called 2 electrons in the subshell. 2 electrons are there in the subshell. After that, so directly we can say that a particular electron of an element is belongs to which subshell, and that element belongs to which group and which period. Directly we can say it. And how can we write the electronic configuration? Already, I think you aware of that. Children. What is that? We will see the diagram. Already we are aware of this diagram, I think so. Once again, we will discuss. This diagram is given by Mr. Euler. This is called as Euler diagram. How can we write the electronic configuration of a particular elements in gravity? For example, if we will observe atomic number is 10, how can we write the electronic configuration? Once we will see here, it is starting from the top onwards. First, we will write the structure. How can we draw? From 1 to 7 shells, we are going to write with the S subshells. After that, by removing of the first subshell in the second column, we are starting with the second number and with P subshell. And in the third line, we have removed first number and second number. And with the third number, we have started and with the D subshell. And similarly, we have removed from the downwards also 7 number is also removed. And after that, so means what? Every column we have to decrease one number on the top, one number on the bottom. And in the last line, we are going to get 4 and 5 numbers with the depth subshell. So how can we start the electronic configuration? By writing the electronic configuration, for example, if we have taken 10 atomic number, that is neon. Neon atomic number is 10. Sir, how can we write the electronic configuration based on the diagram? Means, I will explain.